Continuing on, we are in Module 3, Topic 2, Lesson 4, Activity 2. We are starting on page 444. You have studied equations, which are mathematical sentences formed by relating two equivalent expressions. In this lesson, you'll analyze inequalities, which are mathematical sentences that show one expression is greater or less than another expression. You can use a number line to represent inequalities. The graph of an inequality in one variable is the set of all points on a number line that make the inequality true. The set of all points that make an inequality true is the solution set of the inequality. Underline this, please, right here. Okay. So, and then maybe even underline up here, the graph of an inequality is the set of all points on the number line that make it true. So it says, consider the graphs of the inequalities. X is greater than 3. And this is x is greater than or equal to 3. Describe each line representation. So it looks like here we have an open circle and an arrow pointing to the right. Here the circle is filled in and pointing to the right. Why does one graph show an open circle and the other one show a closed? So if we're going to describe them, let's describe the blue one. I'll put that in blue. X is greater than 3. Has an open circle at 3 and has an arrow pointing to the right. Indicating it includes all numbers greater than 3. Okay, the other one is x is greater than or equal to 3, has a closed circle with an arrow, I'm going to kind of shorten this one, to the right, indicating it includes 3 and all numbers greater. So it says describe the solution set, and we kind of did that. We're going to do it a little bit more. So x is greater than 3. That is not a 3. It would be all numbers greater than but not including 3. The solution set for x is greater than or equal to 3, I should say here, the solution set for, and then each of these. So the solution set for x is greater than or equal to 3 includes all numbers greater than or equal to 3. So it includes 3. How does the solution set of the inequality x is greater than 3 differ from the solution set of x? We kind of answer these one on top of the other here. So x is greater than or equal to 3 and x is greater than 3 does not include 3 And this one includes 3. Okay, pause as you need, moving on. Consider the graphs of the inequalities. X is less than 3 and x is less than or equal to 3. Okay, so we're doing the same thing but with less than. So it's literally going to be the same thing, but when we had greater than, we are going to have less than. Describe each number line representation. X is less than 3, has an open circle on 3 and an arrow pointing left, indicating all numbers less than but not including 3. X is less than or equal to 3. It's the same thing. So it has a closed circle with an arrow pointing left. Indicating all numbers less than and or maybe or including 3. Describe the solution set. X is less than 3. Would be all numbers less than but not including 3. Less than or equal to 3. Oops, I forgot the 3. All numbers less than 3, including 3. How does the solution set to the inequality x is greater than or less than or equal to 3 differ from the one x is less than 3? X less than 3 does not include 3. X is less than or equal to 3 does include 3. You can represent the solution to an inequality on a number line by a ray. Every ray begins at a starting point and goes on forever in one direction. A closed circle means that the starting point is part of the solution set of the inequality. An open circle means that the starting point is not part of the solution set of the inequality. So this one was the x is greater than 3 or x is less than 3. The closed circle was x is greater than or equal to 3, or the x was less than or equal to 3. And this part here for array, or like that. How many solutions does each inequality have? It says in questions 1 through 4. Oh, I guess we need to do the back side of this. Okay. Write the inequality represented by each graph. So the arrow is going left, so my arrow is going to point left. X is less than, it's closed, so equal to 15. This one, it's going to the right, so my inequality arrow my inequality symbol will be going to the right. It does not include the circle, so x is greater than 16 and a half, it looks like. I could write that down here a little bit more in line. Okay, this one is going to the left, so this will go to the left. It is not filled in, so I do not give it the equal to, and it looks like 34 and a half. This one is also an open circle, so greater than 23 here, but it's also going this way, so so x is also less than 23, so we would have to write both of them. I don't even know if I had that in the view. I'm 11 minutes into the video and I can't go back and redo it, so if I didn't, I apologize, and go ahead and take the time to do that now. So another way we could say this would be x is not equal to 23. It could include any number less than 23, any number greater than 23, but not 23. Number 4, graph the solution set for each inequality. So less than or equal to 14. So it's equal to, it gets filled in, and it's pointing to the left. X is less than 55, does not include it, so it's open. Less than goes left. Oh, now it has the number first. 2.5 is less than or equal to x. So first thing I'm going to do is rewrite that with the x first. Now the open part is by the x, so I'm going to write it that way. It actually flips it. And now that makes it easier to graph. X is greater than or equal to 2.5. Okay, and letter D, x is greater than 3 3/10, so probably about in here, going this way. And letter E, x is not 4.2, so we'll put it about there. So it could be anything this way or anything this way. Okay, so then it says on the next page, consider the inequalities in questions 1 through 4. How many solutions does each inequality have? Okay, so that covers 15 and everything less. So it would never end. This one would never end. That would never end. Even this one. The only thing that it doesn't have is 23. It has everything else. So these are all an infinite number of solutions. Can you write an inequality that has no solutions? Okay, so we could say what about x is greater than x? Or if I use numbers like 3 is greater than 3. That is not true. No solution. Like if I said x was 3, that would make it not true. No solutions. Can you write one that has just one? We're actually going to skip this question. I have a note from last year about this to skip this one. Well, I'll try it. So it says x is greater than or equal to x. So if we said x equals 2, it's the or part of this. This says greater than or equal to. So it is possible, if we look at the equal to portion of it, for there to be just one solution if we had like x equals 2. To me, that's a bad question, and we're going to continue on. Number 6, define a variable and write a mathematical statement to represent each situation. Then sketch a graph of each inequality. The maximum load for an elevator is equals 2,900 pounds. So we'll say maybe W for weight. So W equals 2,900. It says the maximum load. So it could be that or less. So it could be less than that or that. So less than or equal to 2,900. The maximum load. It could be, so could it be 2,800? Sure. Could it be 2,901? No. Could it be 2,900? Yes, that would be the maximum. A car can seat up to 8 passengers. So can it seat 8 passengers? Yes. Can it seat 7 passengers? Yes, these are yeses. Could it seat 6, 5, 4, 3, 2, could seat 1. I guess it could seat no passengers. Can it set a negative amount of passengers? Not really. We can't really have a negative person. Can it set 9 people? No. So it could sit 8 people, and I would say down to and including 1 person. Actually, I would do 0 because there could be 0 people in it. So we might say P is less than or equal to 8, but then P has to be also greater than or equal to 0. So it has to be between the two. The book says 8 or less, but you can't have negative. So again, this is not really a question that I'm fond of for you guys, because you can't go negative people. They're implying up to 8 means that you could. No persons under the age of 18 are permitted. So you would have to, your age would have to be under the age of 18. So that would mean 18 would be okay, and 18 and greater are okay. So if your age is 18 or more, you're okay. You must be at least 13 years old to join. So your age, so like age, we're going to use A, same with up here too. Could you be 13? It says at least 13, so yes, you could be 13, you could be 14, you could be 23. Can you be 12? No. So this would be a 13. And we'll see you on the next video to wrap up Talk the Talk.